Hey folks, how's it going? So we want to go over the review. First, on problem number 1, I have a matching. So we're supposed to match 4x, 4 to the negative x, negative 4 to the negative x, and negative 4 to the negative x plus 3 to the given functions over here to the right. So 4 to the x is a basic exponential function. If you were to graph that by hand, you're dealing with just the basic exponential function shape. Crosses at 0, 1. Notice if you were to plug 1 in here, then it would be 1, 4. Although my graph doesn't look like that. So that's things to look out for. So we need a graph that crosses 0, 1, and 1, 4. So the first one is definitely not it. Neither is the second, nor is the third. It looks like the fourth one again. So there's our point, 0, 1, and then 1, 4 right there. So this matches with A, or you can say this is number 4 right here. Now, what happens when you have a negative up here is that in an exponent, as in B. So B looks like 4 to the x, the first one that we graphed, but because the negative is with the x, that's a reflection in the y-axis. So we're looking over here for our number 4 graph, bottom right, that's reflected through the y-axis. And notice that gives us our number 1 graph. So number 1 is associated with B, or B is associated with number 1. Now look at C. C has a negative with the x, just like B does, and that's a reflection in the y-axis. But it also has a negative in front of the function, which is a reflection in the x-axis also. So wow, we got a lot. A reflection in the y-axis and a reflection in the x-axis. Of what? Of the original graph, which is number 4 down here. So reflect that through the y-axis, and that gives you number 1, but then flip it upside down, and that's going to give you number 2. Okay, so this is associated with number 2, which clearly means that D and 3 go together. But I want to talk about that real quick. Notice, what does the 3 do right here at the end? Well, that moves the graph up 3, and more importantly, it changes the horizontal asymptote. So you take the number 2 graph and shift it up 3 units, and the horizontal asymptote is not at the x-axis anymore, which is y equals 0. It moves up to y equals 3. And that's that plus 3 part of there. Okay, so for problem number 2, we're supposed to graph f of x equals 2 to the x, and then f of x equals 2 to the x minus 1 on the same axis over here on the right. So, again, I can't encourage enough, do a t-table. Do a t-table for both of them. So you have x and then y equals 2 to the x. And then maybe let's do a different color. Let's do a blue. And then x and y is equal to 2 to the x minus 1. Okay, you don't have to plug in a ton of points. Exponentials, you should plug in both positive and negative values. I think I'll do that first one in green. So what about negative 2, negative 1, 0, 1, and 2? So 2 to the negative 2, you could type that right in your calculator, or know the relationship of negative exponents means the base and the exponent goes on the other side of the fraction bar, so that's 1/4. 2 to the negative 1 be 1 over 2 to the first, which is 1/2. 2 to the 0, you know what that is 1. 2 to the first is 2, and 2 squared is 4. So if we plot those points, again, negative 2 is 1/4, really small. Negative 1, 1/2, a little bit higher. 0, 1, 1, 2, and 2, 4. Notice no tricks there. I just plugged points in, and we've done this before, so you have a general idea of what it's going to look like. I should label it. This is f of x equals 2 to the x, or I could have just put that was f of x. Now in blue, I'm going to work on the second one. Now here's what I want you to know. is that minus 1 subtracted from the x value means we're moving right 1 unit. So what we could do is take every one of those points and move them to the right. But listen, there's nothing wrong with plugging in points and just seeing if that is what happens. So if I say 2 to the negative 2 minus 1, that's going to be 2 to the negative 3, which is going to be 1 over 2 to the third, which is 1/8. 2 to the negative 1 minus 1 is 2 to the negative 2, which is 1 over 2 squared, which is 1/4. 2 to the 0 minus 1 is 2 to the negative 1, that's 1/2. 2 to the 1 minus 1 is 2 to the 0, we know that's 1. And 2 squared minus 1 is 2 to the first, which is 2. So if we plot those points, negative 2 1/8 is really, really tiny. It's below the 1/4. Negative 1 1/4, again, also below the green graph. 0 1/2, and it also disappeared on me. 0 1/2. 1 1, and 2 2. So look at those points. Look how the green just moved over to the right. And there we go. And then we should label that too. So that's your g function. I'm going to avoid writing all of that there, but we had an f and a g function. So once again, I'm asking you to graph two functions on the same axis, 3 to the x and 3 to the x minus 1. So we have an x column, and then we'll graph y equals 3 to the x, and then we have an x column here. We'll see that in a different color, like pink. We have an x column here, and let's make it not so big pink. And 3 to the x minus 1. So back to the green, what do you want to plug in? How about negative 2, negative 1, 0, 1, and 2? Hey, you know what? I forgot to address, let's go back. I didn't answer all the questions on the last one, then we'll revisit. Notice we were supposed to state the domain, the x-intercept, the y-intercept, the horizontal, and the vertical asymptote for each one. So looking at the green graph, okay, the domain is negative infinity to infinity. That's left to right. It covers everything. The range, it doesn't go below the x-axis, and it doesn't even touch the x-axis. So 0 to infinity. The x-intercept, there is no x-intercept, so I'm going to put none. The y-intercept is 0, 1. And then the horizontal asymptote is y equals 0. There is no vertical. Okay, for the blue graph, which is 2 to the x minus 1, the domain is still negative infinity to infinity, and the range is still 0 to infinity. Notice that didn't change. It still covers everything left to right. Lowest value is 0, but it doesn't touch 0, so I don't include it, and goes up forever. The y-intercept is still 0, 1, and then the x-intercept is none. And also, y equals 0 is the horizontal asymptote right across the x-axis. So these are the same for both of these graphs. Now it's going to be different for the next problem. So we were in the middle of working on that. And the green one, 3 to the x, which actually looks just like 2 to the x, but it's steeper. So this is going to be 3 to the negative 2, which is the same as 1 over 3 squared, so that's 1/9. 3 to the negative 1 is 1 over 3 to the first, 1/3. 3 to the 0 is 1, 3 to the first is 3, and 3 squared is 9. So you plot those points. Negative 2 is 1/9, really, really small. Negative 1 is 1/3, which is a little bit higher. 0, 1, 1, 3, and 2, 9. Again, notice how similar that looks to 2 to the x that we graphed. It's just steeper. Okay, but what does that minus 1 do here? Doesn't move it right 1. That's when the minus 1 was up there with the x. What happens here is the minus 1 moves everything down 1. So we could take every one of these points and move it down 1. Like right here, that negative 2, 1/9 is going to be negative 2. And then right there, which would be, look at it disappear, which would be negative 8/9. Just move it down 1. So this was the point -1 1/3. Again, if I move that down 1, that would be -2/3. This point right here, 0 1, is now going to be 0 0. And this point here, which is 1 3, is now going to be, move it down 1. I tried to move it down 2, right there, okay, which is at 2. And then this point's at 9, is going to be at 8. And I connect the dots, okay. Also, I could have just plugged values in. So for instance, if I plug in -2, be 3 to the -2 minus 1, which would be 1/9 minus 1, 1/9 minus 9/9 is -8/9. We even mentioned that. Or if I plug in 0, be 3 to the 0 minus 1, which would be 1 minus 1, which is 0. That's the point we have. Now there's something really important I want to point out here. Whenever you move a graph up or down, it also moves the horizontal asymptote up or down. So the pink graph has a horizontal asymptote at -1. So let's list everything again. So the domain is -infinity to infinity for 3 to the x for the green graph. The range is 0 to infinity. There is no x-intercept. The y-intercept is 0, 1, and the horizontal asymptote is y equals 0. But for the pink graph, things are a little different. The domain is still -infinity to infinity, but the range, look, everything is moved down. Instead of 0 to infinity, it's going to be -1 to infinity, and it never touches -1. Okay, there is no x-intercept, but the y-intercept, look, it moved down also, is at 0, 0. What about the horizontal asymptote? That's y equals -1, and there is no vertical asymptote. Okay, for question C, again, I have an x and 3 to the x, which we've already graphed, and then for the next one, the transformation, I have x and -3 to the x. Okay, so we can plug in -2, -1, 0, 1, and 2. Now, you could go to the last problem and realize that's 1/9, 1/3. When you plug in 0, you get 1. 3 to the first is 3. 3 squared is 9. Let's go ahead and plot those. So -2, 1/9, just like the last time. Then 1/3, and then 1, and then 3, and 2, 9. And there's my original function. Now, what does this negative in front do? Okay, real quick. The negative in front of a function, remember, is a reflection in the x-axis. So this thing is going to flip upside down. But if you don't know that, hey, just plug in points and you'll see that it flips upside down. So what do you want to plug in? How about the same numbers? -2, -1, 0, 1, and 2. So this is going to be -3 to the -2, which is going to be -1. Remember, this is negative, stays out front, over 3 squared, so this is a -1/9. -3 to the -1. It's going to be -1 over 3 to the first, which is -1/3. -3 to the 0, or -0 if you like, which is -3 to the 0, which is 1. Anything to the 0 is always 1. -3 to the first is -3, and -3 to the second. And notice the negative is not raised to the second. The only thing that's raised to the power is the 3. The negative is just thrown in the front of the answer, so this is -9. And if I plot those points, so I've got -2, -1/9, again a reflection right there through the x-axis, -1, -1/3. It's like there's a mirror right there along the x-axis. 0, I put 1, but y'all, that's -1. You might have caught that. And then 1, -3, and 2, -9. I connect the dots. And I get my second graph. Okay, so once again, let's talk about domain, range. We already know everything for 3 to the x. We did it. Domain's -infinity to infinity. Range is 0 to infinity. The x-intercept, there's not one. Y-intercept is 1, 0. And y equals 0 is your horizontal asymptote. But now for the next graph, -3 to the negative x, the domain is -infinity to infinity. The range is different, low to high. It goes from -infinity to 0 with the parentheses, the opposite of the green graph. What about the x-intercept? Still doesn't cross the x-axis, so there's no x-intercept, but there's a y-intercept, and it is 0, -1. Horizontal asymptote is still y equals 0. It's just upside, the graph's just upside down. It still approaches the same line. All right, for our next example, let's try the same points, -2, -1, 0, 1, 2. So if I evaluate 1/2 to the -2, you know what you need to do when you have a negative exponent? Flip. So that's the same as 2 over 1 to the +2. And 2 over 1 is 2. 2 squared is 4. All right, let's try it again. 1/2 to the -1. To make that negative exponent positive, whenever you have a fraction inside, flip that fraction upside down. 2 over 1 to the +1. Of course, we know 2 over 1 is 2 to the first is 2. All right, how about 1/2 to the 0 power? Well, that's 1. 1/2 to the first power is 1/2. And then 1/2 squared, think about that. That's 1/2 times 1/2. And when you multiply fractions, you multiply numerator times numerator, which is 1, and denominator times denominator, which is 4. And if I plot these points, so I've got -2, 4, -1, 2, 0, 1, 1, 1/2, and 2 is really tiny at 1/4. Now this feels like what we've been doing all along, but it's backwards. And that's because our base is a number between 0 and 1. Anytime your base right here is between 0 and 1, and you have a regular x for your exponent, which makes it, that's what makes it an exponential function, the graph is going to be falling left to right. But now, what's going on with this negative, remember what that negative does, that's a reflection, and I can't write reflection, that's a reflection in which axis? It's going to be the y-axis, right, because of the negative is with the x. So you could plug in all these same points or reflect them through, like -2, 4 is going to reflect through, and now it's going to be right here, right, which is +2, 4. Or right here, -1, 2 is going to be +1, 2. 0, 0 is going to be the same place. This one flips through, and this one flips through. And it reflects just like that. And that's one way to think about it. Or you could plug in points, -2, -1, 0, 1, and 2. Let's do that. So that's 1/2 to the negative of a -2, which is really 1/2 to the second power, which is 1/4. Notice we have -2, 1/4 plotted right there. 1/2 to the negative of a -1 is 1/2 to the first, which is 1/2. 1/2 to the -0 is going to be 1, because that's anything to the 0 is 1. 1/2 to the -1 power, because the negative, remember, is in the equation. So that's going to be, you flip it upside down, it's going to give you 2. And this is the last one's 1/2 to the -2. Flip it, it's going to give you 4. So those are the same points we plotted. There's one more way to think about that. You could go ahead and handle this 1/2 to the -x. Remember that negative, you're supposed to flip this upside down. That's the same as 2 over 1 to the +x, which is 2 to the x, which is what we have graphed in orange. All right, now let's make our list again of domain, range, x-intercepts, y-intercepts. For the green graph, the domain is -infinity to infinity, left to right. Range, 0 to infinity, low to high. Okay, how about x-intercepts? None. I'm not going to write it down. It does not cross the x-axis at all. How about y-intercept? Green graph. It's going to be 0, 1. Okay, what else? Horizontal asymptote, y equals 0. And I've got a problem I got to go back and fix. I just thought about something. Okay, orange graph. How about the domain of that guy? Orange graph, negative infinity to infinity, because remember it's just 2 to the x. Range, 0 to infinity, low to high. X-intercept, none. It doesn't cross the x-axis ever. Y-intercept, 0, 1. Horizontal asymptote, y equals 0. The only difference between these two graphs is the orange one's increasing and the green one's decreasing. And remember, whenever your base is between 0 and 1, your graph is decreasing as long as it's just raised to the x power. When we threw in that negative, that's a transformation. But let me tell you what I forgot. And you might have caught this when I did it. Look, I said that this pink graph right here on 2b had no x-intercept. That's not true. And again, you might have caught that. I'm trying to erase. It won't let me. There we go. Look, there's an x-intercept right there. It's 0, 0. And I put it for the y-intercept. And I should have put it for the x-intercept, but I just didn't because I wasn't thinking and I was going too quickly. So x-intercept, be super careful. That's 0, 0. Okay? Now, back where we left off. So I think we've got all that done. We've got one more graphing problem to do that's like this anyway. Okay, so we've got just our basic function x, f of x equals e to the x. Okay, what do you want to plug in? Let's stick to what we've been plugging in. Now, you're not going to do this without a calculator though. So e is what we call the common base, okay? Or actually the natural base. The common base is base 10, but the natural base, and it is a button in your calculator. You'll see it usually above the ln button. So on my calculator, I have to hit second ln, and then type in the -2 for the exponent, put parentheses around it. So this is going to be 0.135. I'm just going to put 0.14. Now, I really can't graph any better than the tenths place, the 0.1, but I just want you to see what you should get in your calculator. Next one, e to the -1. And so, again, I hit second and the ln button, type in -1, close out the parentheses. That's going to give me 0.37. Okay, now e to the 0, we know is 1. E to the first, now we've talked about what e to the first is, so second e to the first gives me 2.72. And then e to the second. Second, and then that natural log button, which gives me e, and then type in 2 for the exponent, 7.39. Okay, do my best I can to plot these. -2.14 is going to be really, really tiny. -1.37, a little bit higher. 0, 1, 1, 2.7, and then 2, 7.3. That's like 6.3. I didn't go high enough. There we go. Connect the dots. This thing looks very, very similar to 2 to the x because it fits right between 2 to the x and 3 to the x. Okay? Now, let's look at this transformation. Notice I'm taking my x, I'm dividing it by 2. That's actually a horizontal stretch. And right here, I'm multiplying my function by 2, which is a vertical stretch. Now, don't get hung up thinking about it that way. Just plug in values and see what happens. Okay? I'm going to change my colors. You just keep working. So let's do -2, -1, 0, 1, and 2. So this is going to be 2e to the -2 divided by 2, which is going to be 2e to the -1. And that's what I want to type in my calculator. 2 times, and hit second e into the -1 power. And that's going to give me 0.74. Okay, now 2e to the -1 divided by 2. And again, I'm just plugging in each of these numbers in that little spot right there for x. And seeing what I come up with. So I'm going to type that in my calculator. So 2 times, and I'm going to hit my second ln button, which gives me the e, and type in -1/2. Close out my parentheses, and that gives me 1.21. And then 2e to the 0 over 2, Well, you know 0 over 2 is 0, so that's 2e to the 0. Now, e to the 0 is 1. 2 times 1 is 2. 2e to the 1/2. Next one, I'll type in my calculator. 2 times second ln button, and then enter a 1/2, or 1 divided by 2 in the exponent, 3.30. Went around 2e to the 2 over 2. Well, that's 2e to the first. So again, I'm going to type 2 times and hit second ln button to get the e. Type in a 1 for the exponent, 5.44. And let's just plot and see. So negative 2.74. And notice that's higher than the green graph. Negative 1, 1.21. Okay, 0, 2. All right, 1, 3.3. Still higher. 2, 5.44. And then it switches. Interesting, right? They have an intersection point. They cross each other, so things change. Now, we're supposed to label the domain, the range, the x-intercept, the y-intercept, and the horizontal asymptote. For the green graph, the domain is negative infinity to infinity. The range is 0 to infinity, very similar to all the graphs we've done. The x-intercept, the green graph does not have one, so none. The y-intercept is 0, 1. Horizontal asymptote, y equals 0. Parentheses not required. Now, for the graph 2e, the x over 2 domain, look, it goes from negative infinity to infinity. The range, low to high, it looks like it still approaches the horizontal asymptote of y equals 0, so 0 to infinity. It does not have an x-intercept. The y-intercept, you see that thing, is right there in the blue, so that is 0, 2. And then the horizontal asymptote is still y equals 0. It still approaches that line.